Dear students, let us see some tutorials related to Mason's gain formula. Here the question is, find the overall transfer function of the system whose signal flow graph is shown in the figure. So there is a signal flow graph is given here. We have to find the overall transfer function by using the Mason's gain formula. So as we all know, the Mason's gain formula is given by the t, that is a transfer function, equal to transfer function is given by 1 by delta sigma pk delta k, 1 by sigma pk delta k divided by delta. So first of all, here we have to find the forward paths, number of forward paths. Here you can see in this figure the number of forward paths is given by, so we can find the number of forward paths initially. So the first forward path, so forward path, we know that should start from here, from the input node, and that should here you can see this path like this, it goes like this, and this path here that ends at the output node. So this is a forward path. Is there any other forward path? So from 1 to 2, then you can see 2 to 5, there is a path from 2 to 5, then 5 to 6, then 6 to 7, 7 to 8. Is there any other path available? We can see no other paths are available here. So there are only two forward paths here. So the value of k is given by 2 here, means the number of forward paths equal to 2. So those forward paths are shown here. You can see these are the forward paths. Now we have to find the gains of the overall gain of the forward path. So in the case of first forward path, the total gain is given by 1 into G1 into G2 into G3 into G4 into G5 into 1. Okay, so G1, G2, G3, G4, G5. That is the gain of the first forward path. Gain of the second forward path is given by 1 into G6, G4, G5. So we can consider it as a G6, G4, G5. That is the gain of the second forward path. Now we have to find the loops, individual loops, and we have to find the individual loop gains. So how many loops are here? Once again we have to check the signal flow graph and find the loops. So starting from here, is there a loop like this goes here, but you can see this one is also in the forward direction, so we cannot consider it as a loop. Okay, so is there any other loop? Let us see. So we can see here is a loop, so this is a loop here. So here you can see the second loop. You can see here this one comes back here, that is a loop. Is there any other loop? Yes, here is a loop. Let us see here, from 6 to 7 and then back to 6. So as a whole here we have found 3 loops. The first one is this one, second one is this one, third one is this one. So I think that there are no other loops. Individual loops are present here. Okay, so there are 3 loops and we have to find the loop gains. It's very simple. The first loop gain is given by P11. So individual loop is here, so that is why we first loop P11. Okay, second loop is termed as P21. Third loop is termed as P31. Okay, So the first loop gain is minus h1 g2, second loop gain is g2 g3 minus h2, and third loop gain is g5 minus h3. Okay, so these three are noted here. Now the next topic is next thing we have to next step is we have to find the gain products of two non-touching loops. So we have to identify the non-touching loops here, two loops which are not touching each other. So you can see here in this figure what happens here. Okay, so here in this figure we can see okay, here in this figure this loop and this loop, these are two non-touching loops. Okay, these two loops, in fact these two loops are touching loops. So this loop and this loop, two non-touching loop. Again you can see this loop and this loop, these are also two non-touching loops. So there are two non-touching loops are here. First one this one and this one, second one is this loop and this loop. Okay, so we have to, in this way we have to identify the two non-touching loops. So next question will be, is there any three non-touching loops? That means three loops which are not touching each other. But we cannot see any three non-touching loops here because these three loops, two of the loops touch each other. So there is no three non-touching loops here. Okay, only two non-touching loops. So we have found out the two pairs of two non-touching loop here. Now we can find the gain products of these two non-touching loops. So this is the first two non-touching loops here. So G2 minus H1 and the product of the and we have to multiply it with the gain of the next loop, that is G5 minus H3. So as a whole this will be equal to H1 H3 G2 G5. Okay, G2 G5 H1 H3 minus and minus, that will become plus here. So that way we have to find the gain products of two non-touching loop, that is to be taken as a P12. Okay, first two non-touching loop. Next one is the second two non-touching loop, that is P22, that is P21 into P31. Okay, so this is the second loop and our third loop. Okay, so we have to find the overall, we have to multiply the gains G2 G3 minus H2 into G5 into minus H3. So that will become G2 G3 G5 H2 H3. Okay, thus we have found the two non-touching loops and find their gain products. Next topic is, or next step is, we have to find the, we have to calculate the delta and delta K. So what do you mean by delta? So how to find the delta? Delta is, in fact, the formula is that 1 minus the sum of gains of the individual loops plus sum of gain products of two non-touching loops. Okay, so 1 minus individual loops, three individual loops are there. So P11, P21 and plus P31. Plus there are two pairs of two non-touching loops as the P12 and plus P22. So we have already found out these values here. So we have to simply put it here and final answer will be 1 plus G2 H1, G2 G3 H2 like that. Okay, thus we need to substitute the values. Then we have to find delta 1, delta K. Here delta 1 and delta 2. So what is delta 1? Delta 1 means we have to calculate delta by selecting only the loops which are not touching the first forward path. അപ്പോൾ ഈ ഫസ്റ്റ് ഫോർവേഡ് പാത്ത് P1 touch ചെയ്യാത്ത loops മാത്രം എടുക്കുക. We have to take only the loops which are not touching the first forward path. Here we can see that all the loops, all the three loops are available here. മൂന്ന് loop ഉണ്ട്. ഈ three loops first forward path touch ചെയ്യുന്നുണ്ട്. That is why there is no loop which is not touching the first forward path. So that becomes, that is why all these values become 0, and what remains here, delta 1 becomes 1. And if you consider delta 2, that means in the case of second forward path, is there any loop not touching the second forward path? So we can see this first loop P11 is not touching the second forward path. Okay, so you just look at the diagram, then you can see the first loop is not touching the second forward path. Just look here, you can see here. So the second forward path, so we are thinking of the second forward path. This is the second forward path. Okay, in this way that goes. So this loop, only this loop, so we consider this loop as P11. This loop is only one loop which is not touching the second forward path. Okay, so any two non-touching loop or anything like this, we cannot see any other loop here. So only one single loop which is not touching the second forward path. So based on that, we have to find the delta 2. We have to find delta 2. So what is delta 2 here? So delta 2 will be 1 minus the individual loop P11. Okay, that is equal to 1 minus, what is the gain of P11? That is minus G2H1. So it will become minus into minus, that will plus, so 1 plus G2H1. Finally, all these values we have to put into the formula P1 delta 1 plus P2 delta 2. So P1 is the first forward path gain, P2 is the second forward path gain, delta 1 we have found that is obtained as 1, delta 2 here we obtained as 1 plus G2H1. So these values are to be substituted here in the numerator, and denominator is the delta. So delta we have already found out, so the denominator is to be put as delta. Thus we have finally obtained the overall transfer function of the given signal flow graph by using the Mason's gain formula. So here we have to find out, initially we have to find out the forward paths P1 and P2. There are only two forward paths here, so we have to find all the possible forward paths, and then we have to find out the delta 1 and delta 2. Okay, in order to find out delta, we know that in order to find out delta, we have to find the individual loops first of all, then we have to find the gain products of two non-touching loops. Okay, two non-touching loops, and in fact next step is, in fact, we have to subtract the gain products of three non-touching loops if available, three loops which are not touching each other, but that kind of three non-touching loops is not available in this question. Okay, so thus we have found out delta 1, delta 2, P1 and P2, and substituted it in this formula to obtain the final answer, that is the overall transfer function. Thank you.